Welcome everyone. We are discussing continuity. We are discussing only basic problems of continuity, that is board's problem. So, I have already given geometrical concept definition of continuity. So, what is definition? A function fx is said to be continuous if limit extends to a plus fx equals to limit extends to a minus fx equals to fa, or limit extends to a fx equals to fa. So, we have already solved some problems, 6 or 7 problems using this one. When condition is given on not equals to, then we have used this definition. Now, when condition is given for greater than value, less than value, equal to value, we use this definition. Although these definitions are equivalent. Now, look, we consider a simplest problem. Fx equals to 2 minus x, x less than 2, 2 plus x, x greater than 2. Examine continuity at x equals to 2. We are considering continuity at a specified point. So, what is the point? A is replaced by 2. So, we have to find functional value. F2. So, look, fx is equals to this. F2, x equals to 2. So, this will be to this restriction. F2, so what is the function? 2 plus x. But you have to replace x by 2. So 2 plus 2. So this is 4. So this is functional value. Look it again. You see the restriction. F2, so this is less than 2. It is greater than equals to 2. So it is the restriction. F2. So, what is the function? 2 plus x. But f2 is replace x by 2. So, f2 is 4. Then, left hand limit equals to limit x tends to 2 minus fx. Limit x tends to 2 minus. Look, 2 minus, that is less than 2. So, what is fx? Fx is 2 minus x. Then you know 2 minus is very nearer to 2. So, if it is 2 minus or 2 plus, we always replace x by 2. So, 2 minus 2, so this equals to 0. So, what is value of the left hand limit? Left hand limit is 0. So, they are not same. So, you can say the function is not continuous at x equals to 2. But you try to calculate right hand limit. Right hand limit is x tends to 2 plus fx. So, for greater than 2, you look for greater than 2. So, what is the fx? Fx is 2 plus x. Then put x equals to 2. So, 2 plus 2 is 4. So, what we are getting? LHL not equals to RHL. So, fx is not continuous at x equals to 2. So, I have already stated no need of calculating RHL here because LHL is 0 and functional value is 4. They are not same. But they are not same. But here we have calculated right hand limit to know how to find right hand limit. Then problem number 2. So, function is given 0 to 1 x square plus x plus 1 at x equals to 1, this is 1, 2x square plus 5x minus 6, 1 not included but 4 is included. You must see the restriction. So, you see the language. What is the language? discuss continuity at x equals to 1. So what is functional value? So write f1. So what is f1? f1 is functional value. To this restriction, f1 is given 1. So what is RHL? Limit, right hand limit, 1 plus fx. So look, 1 plus means greater than 1, but very small amount. That is, it is very nearer to 1. You do not think it is 2, this is 3. Greater than 1, but in very small amount. So look, first restriction is less than 1. Second restriction is x greater than 1 to 4. So for greater than 1, what is the fx? 2x square plus 5x minus 6. Then you put x equals to 1. So 2 into 1 square, 5 into 1 minus 6. So 7 minus 6 equals to 1. So right hand limit is 1. Now what is LHL? Limit x tends to 1 minus fx. 1 minus. So lesser than 1, but in very small amount. Lesser than 1. So this will be the fx. Lesser than 1. So x square plus x plus 1. So you modify it. This is suppose minus 1. So x square plus x minus 1. So if it is 1 minus, means it is very nearer to 1. Do not put minus 1. 1 minus means 0.99999. That is, it is very nearer to 1. We put x equals to 1, not minus 1. Remember. So this is 1 square plus 1 minus 1. So this is 1. So finally what we are getting? RHL equals to LHL equals to F1 equals to 1. All values are 7. So fx is continuous at x equals to 1. So look, it is given greater than, less than, equal to. That is why we are using this definition. Next, problem number 3. This is most important problem. So this is problem of 4 marks. So look, function is given for greater than 4, less than 4, equal to 4. So here modulus sign is given. So try to recall the modulus sign. This is our definition. X minus a. If it is x minus a, restriction is on a. So it is positive when x greater than a. It is 0 when x equals to a. Equals to minus x minus a, x less than a. For less than a, it is negative. For greater than a, it is positive. Equal to a, it is 0. So this is our general definition. So if it is x minus 4, so restriction will be on x minus 4 equals to 0. That is at x equals to 4. So greater than 4, it is positive. Equal to 4, it is 0. And negative, it is x less than 4. So this will be our working tool. So all of you know it. Then you start. So functional value f4 equals to a plus b. Right hand limit equals to limit x tends to 4 plus fx. 4 plus means greater than 4. You see the restriction. This is greater than 4. X minus 4 mod x minus 4 plus b. So for greater than 4, so we have already discussed this one is positive. So it is x minus 4 is cancelled. This is 1 and this is constant. So 1 plus b is right hand limit. 1 plus b. Now left hand limit x tends to 4 minus fx. So for lesser than 4. So what is fx? Lesser than 4. X minus 4 by mod x minus 4 plus a. So lesser than 4. So this is negative. So x minus 4 is cancelled. So this is minus 1 plus a. So we are getting left hand, right hand and this. Now find a and b if fx is continuous. It is given that function is continuous. Find a and b. So since fx is continuous, at x equals to 4, therefore f4 equals to right hand limit equals to left hand limit. So what is f4? A plus b. What is right hand limit? 1 plus b. What is left hand limit? Minus 1 plus a. So solve and you find a and b. You solve this equation taking one at a time. So look, a plus b equals to 1 plus b. So a equals to 1. A plus b, 1 plus b. So a plus b minus a plus 1. Minus a. Minus 1 plus a. So b equals to minus 1. B equals to minus 1. So what we are getting? Find values of a and b. So a equals to 1, b equals to minus 1. This will be answer. So look it again. Condition is imposed on less than equal to 4. So left hand limit is minus 1 plus a. Right hand limit and functional value is a plus b. Use definition of continuity. Solve and you find a and b. Now we consider three most important problem of board. So problem number 4, 5, 6. So problem number, there also problem of Wbjee. 1 or 2 marks problem. So we first consider problem number 6. Fx equals to sin 3x by tan 2x, x less than 0, 3 by 2 x equals to 0, or for greater than 0, log 1 plus 3x by e to the power 2x minus 1. Verify continuity at x equals to 0. Verify continuity at x equals to 0. So look, restriction is greater than, less than, equal to. So we use right hand limit, left hand limit and functional value. So what is f0? So look, f0 is given directly. This is 3 by 2. So this is 3 by 2. This is f0. Now what is left hand limit? Left hand limit equals to limit x tends to 0 minus fx. So limit x tends to 0 minus, what is fx? For less than 0, this is sin 3x by tan 2x. Now it is problem of trigonometric limit. So we know sin 3x by x equals to 1. We know it, and also tan x by x equals to 1. Sin x by x 1, tan x by x 1. So limit x tends to 0, tan 2x. So you divide it by 3x and balance it by 3. This is 2x, balance it by 2. So omitting one step. So sin 3x by 3x is 1. So 3 extra. Tan 2x by 2x is 1. 2 extra. And this x is cancelled out. So meaning remaining 7. So what is the value of the numerator? 1 into 3. 1 into 2. So what is the left hand limit? Left hand limit is 3 by 2. Now f0 is also 3 by 2. They are same. Now we have to verify right hand limit. So right hand limit equals to limit x tends to 0 plus fx. So for 0 plus, you look the restriction. This is log 1 plus 3x by e to the power 2x minus 1. By e to the power 2x minus 1. Now try to recall the standard result of limit. So log 1 plus 3x by, if it is 3x, then it is 1. So make it balance by 3x or 3. And e to the power 2x minus 1 by 2x. So make it balance by 2. So by fundamental limit theorem, limit of numerator, limit of denominator. Now look, log 1 plus 3x by 3x into 3 and log e to the power 2x minus 1 by 2x. So look, 3 balance, 2 balance, and x is cancel out. So what we are getting? So after this is 1 into 3, this is 1 into 2. So this is 3 by 2. This is 3 by 2. So finally what you are getting, f0 equals to 3 by 2, left hand limit equals to 3 by 2, right hand limit equals to 3 by 2. So final calculation is f0 equals to RHL equals to LHL equals to 3 by 2. So fx is continuous at x equals to 0. So I am saying repeatedly, if it is board problem, we do not use L'Hospital rule. We solve problem using L'Hospital rule for problems of competitive exam. Now, next problem. Problem number 5. So, less than 0, equal to 0, greater than 0. Fx is given. Find if fx is continuous at x equals to 0. So, you have to use this definition. So, what is f0? f0, it is given a. So, then we calculate RHL. equals to limit x tends to 0 plus fx. Now what is 0 plus? For 0 plus, so what is fx? Root x. 16 plus root x minus 4. Now it is problem of limit. Root over sign is occurring. So you have to use method of rationalization. So try to recall. Limit x tends to 0 plus. So root x unchanged. 16 plus root x plus 4 rationalization. And it will be 16 plus root x minus 4 plus 4. So this is 16. Omitting one step. This whole square equals to 16 plus root x, 4 square. So omitting one step. So 16 cancel. So limit x tends to 0 plus. So root x into 16 plus root x plus 4. So root x cancel. X tends to 0. So our main aim is to cancel x equals to 0. Then put x equals to 0. So 16 plus root 0 plus 4. So this is 8. So what is the value of the right hand limit? Value of the right hand limit is 8. Next, we consider left hand limit. So what is left hand limit? Left hand limit equals to limit x tends to 0 minus 1 fx. 0 minus, for 0 minus 1 minus cos 4x by x square. So if you put x equals to 0, 1 minus 1, this is 0 by 0 form. So you cannot use L'Hospital rule, or you cannot put x equals to 0. So try to convert it into standard limit. Now look, 1 minus cos 2x, it is 2 sin square x. If it is 2x, this is x. So use the standard formula, 2 sin square 2x by x square. So 2 is outside. Limit x tends to 0. This is sin 2x. So to get standard limit, this must be 2x. So total whole square, because squaring occurring. So sin square 2x is balanced. X square is balanced. So 2 square at the numerator. So to make it balanced by 2 square. So actually continuity is problem of solving limit. So 2 into 2 square. This is 1. So 8. 8. Now find value of a if fx is continuous at x equals to 0. So what is our definition? F0 equals to LHL equals to RHL. So what is F0? A. What is LHL? 8. What is RHL? 8. So A equals to 8. A equals to 8. So this is most important problem. Now problem number 4. So it is also problem of competitive exam of Wbjee and JEE Main. So find ABC if fx is continuous at x equals to 0. So what is f0? f0 equals to c. Now what is LHL? Limit x tends to 0 fx, 0 minus. So limit x tends to 0 minus Sine a plus 1 into x plus sine x. Now use standard limit. You know sine x by x is 1. So you write it in this form. Next, as x tends to 0, this argument tends to 0. So you must remember, if x tends to 0, this argument tends to 0. So then argument is balance. This is a plus 1 and this is standard limit 1. And this is 1. 1 into a plus 1 plus 1. So a plus 2. So what is left hand limit? Left hand limit is 2. Next, RHL. So limit x tends to 0 plus fx. Limit x tends to 0 plus x plus bx square minus root x by b into x to the power 3 by 2. Now, it is problem of limit. Obviously, it is problem of solving method of rationalization. So look, root x is common. So this is root over 1 plus bx minus 1. So b into x. X to the power 3 by 2. So x cancel. Since x not equals to 0. Now use method of rationalization. So this step to be noted, only this step. Root x common, this is most important step. So x into, what is rationalization factor? And 1 plus bx minus 1. So this is limit x tends to 0 plus bx by 1 cancel, x into root over 1 plus bx plus 1. We have already stated this rationalizing factor creates no problem if you put x equals to 0. X tends to 0, so your main aim is to cancel x. So x cancel. So put the value. So b by 1 plus 0 plus 1. So this is b by 2. B by 2. So what is right hand limit? Right hand limit is b by 2. Now use definition. Since fx is continuous at x equals to 0, so f0 equals to RHL equals to LHL. So what is f0? f0 equals to c. What is RHL? RHL is, this is obviously 0 plus. So b by 2. And what is LHL? LHL is so look, this is b. 1 plus bx, there is a b at the denominator. B at the denominator. So this is, it is, look, this is bx and x into, not x into, this is, I think there is a b at the denominator. So make it correct. Make it correct. It is bx, b into x. So b at the denominator. So this b also cancel out. So this b also cancel out. This is half. Sorry. So you complete this one. So this is half. This is half. And what is the left hand limit? Left hand limit is a plus 2. So you calculate it again. So right hand limit will be half. So you are getting c equals to half. So what is a? Half minus 2. So this is minus 3 by 2. A equals to minus 3 by 2. C equals to half. Now what is our problem? Find ABC if fx is continuous at x equals to 0. So we are not getting any value of b. So if we do not get any restriction involving b, we say b can take any real value. B can take any real value. So look, since b is at the denominator, so b not equals to 0. B not equals to 0. So what will be our condition on b? So condition is b belongs to real not equals to 0. That is b is any non-zero real number. Why we are concluding this one? Because we are not getting any condition in terms of b. But b is at the denominator, so if b equals to 0, this is undefined. That is why we are taking b not equals to 0. So this is also problem of board as well as competitive exam. So part 2, this is also for Wbjee and JEE main. So today, through this video, we have solved some important problems of continuity for board as well as competitive exam, mainly for Wbjee, using condition of this. Right hand limit equals to left hand limit equals to fx, if fx is continuous. So I will discuss continuity in sequential order. Basic problems, then problems of competitive exam. So thank you for today.